My name is Dominic Sett. I work with an engineering company in town called McKinstry. My title is project director. Last year, Sarah and Amy asked us to give kind of an HVAC 101 to her group, kind of go through what kinds of systems bring air into spaces, how they run, impacts of filters, and that sort of thing. So we are revisiting this subject in kind of a micro level for this class. Heating, ventilation, and air conditioning. So what kinds of systems in your building bring fresh air in? The code will tell you that for a space like this, we need, say, 0.3 CFM of fresh air per square foot. So the engineer would size the mechanical equipment to deliver a measured amount of ventilation air to the space. The balance of the air we would heat and cool. So I'm going to guess that these diffusers are probably delivering 200 CFM per device. Some fraction of that, maybe 10%, is actually fresh air. Obviously impacted during the smoke season. So some things we can do to mitigate that. We can't shut off the ventilation air. There are certain strategies that we employ to deal with whether it's wildfire smoke. In the school environment, a lot of times it's bus fumes, diesel bus fumes. So maybe the buses line up on the west side of the building every single morning. Well, we can grab that equipment that is delivering air to those spaces and minimize that outdoor air during that period of time. So we can do the same thing with wildfire smoke. We want to talk about what kinds of considerations there are for adding filters to your equipment, what impacts the filters have on the systems, whether they're clean or dirty, and how the machinery might be negatively impacted. So, what kind of systems do you have in your building? Do you have rooftop unit van? I've got some examples just to kind of jog your memory. My guess is that most of you folks work in a commercial building, probably has a rooftop unit, does some air conditioning, does some heating, delivers a measured amount of ventilation air. That's pretty fair. I want to run through a couple examples of things in your building that may be introducing outside air. Since we're talking about wildfire smoke, we don't have a lot of boiler use in the summer unless it's a critical environment. You'll find that at hospitals, the theme is we make really cold air and we send it everywhere, and we reheat it at the zone level, typically with a boiler. You might have domestic water generation that is done by a boiler plant. So the boiler is going to bring air into the building. In this case, it's going to bring in directly to the unit, so wildfire smoke isn't necessarily going to impact this scenario. Sometimes there'll be a big louver on the mechanical room wall that will open and allow ventilation air every time the boiler fires. So there isn't a ton we can do with that. Ideally, that boiler plant and that associated louver are far enough away from the occupants. We really can't tell the hospital, you can't have hot water during this period because of the combustion air needed. But some of the devices that actually heat and cool the spaces, this is probably the most simple. If you go into your kid's classroom, this is a unit vent install. Big box against the outside wall, louver on the outside, brings in a measured amount of fresh air, heats and cools, or recirculates. So here's an opportunity where the filter, if you have questions about where your filter is going to be, it's always going to be in the path of the outside air, so whether it's a rooftop unit or this guy. So if we were thinking about increasing the MERV capability of our filters, this is the space, and I heard daycare providers, seeing these in a lot of daycare units as well. So single thermostat on the wall, little tiny fan, but again, access to outside air. So in this environment, if the buses are pulling up in the morning, we would make sure that this outside air damper is disabled for 90 minutes. We could do the same thing during wildfire. A gym H&V, so stands for heating and ventilation. Again, the theme is the same. We take in a measured amount of air depending on the use of the space. We heat it and cool it based on the use. Anybody have an H&V where they work? A different kind of air handler. This is an exhaust recovery ventilator. This is where we are trying to rob some of the heat that we're purging from the building and kind of re-entrain that into the supplier that we're delivering. So an energy saving idea, but again, we have outside air, the opportunity to add an increased filter if we're having particulate effects from the occupants. This is probably what we have in this building. So we have either a ground-mounted air handler that delivers air, or a rooftop unit that delivers air right to these diffusers. There might be something called the Vav Box between the machine that makes the air and what is delivered. That stands for variable air volume. So it's picking and choosing how much fresh air we get in the space based on what the thermostat wants and what the CO2 levels are in the room. A lot of times we'll be monitoring CO2, so if it starts nodding off, sensors going up, we can increase the ventilation rates based on that rise in CO2. Another example, heat pump. So using either the ground or the air as a heat sink to heat or cool the space. Same theme, we have outside air that's introduced to all of these processes. Various filter types. So we rate filters on what we call a MERV rating, minimum efficiency recording value, sorry. So basically what that means is how small a stuff we can capture with the filters. I think that my residential furnace probably has a MERV 8, so you can see based on these emojis, the kinds of stuff that the manufacturer says that we can capture out of that airstream. When we're talking about wildfire smoke, I know the other day Sarah said 13 or greater was kind of the standard. That's kind of this range here, picking up the heavier particulates. The MERV filters, the higher the MERV rating, the harder it is to push air through the filter. So we can't just slap in a stack of filters into our existing HVAC system. It's going to have fan performance effects. You might use a little bit more energy. So we have to know what we have and the effect that it's going to have on the system when we add a higher MERV rating filter. So this chart is showing us how efficient the different MERV rating filters are at capturing different size particulates. So the smaller the particulate, we do a much better job of grabbing the small particulate with the higher MERV rated filters. So this is kind of the data that supports a higher MERV rating is harder to push air through. So the fan is going to ride a little bit differently on its curve. We might deliver slightly less air to the spaces. We might burn a little bit more fan energy because we have more to push through. So I guess the point is I'm going to leave a stack of cards behind. So if you have questions about your system, I'd be happy to answer them. You could tell me you have unit vents, you have rooftop units, and I could hope to address the impacts of adding additional filtration on those units. Kind of covered it. We're gonna use a little bit more energy. Probably not going to deliver as much to the zone level. Machine's working a little bit harder, but the benefit is we're going to get a lot more of that particulate out of the air. So hopefully there is a person that manages your facility operation and understands the equipment and the impacts that some of these things might have. If you work in a critical environment, especially IT rooms, I know that Al out of DirecTV has some dedicated IT spaces that are served by dedicated units. Again, just be aware that if you're changing that environment, somebody in the operation should be aware of what you're doing and what the effects it might have. For some of the more sophisticated systems, most of the commercial spaces, I guess we have some. This is pretty simple stuff. This could be your home furnace. Again, the only thing important is there's an arrow on the filter, which way we're pushing the air. It'll still work in the other direction, just not as well. So anyway, some of the more complicated commercial buildings have what we call a digital control network, where we have thousands of points of data per building, sometimes per pieces of equipment. And in this example, we can actually see in the unit vent bus example, we can actually grab these outside air dampers. This looks like Al's building a little bit, I think. and we can adjust those minimum outside air flow rates, or we can close them all together in a super smoky environment. And those things can have time delays. There could be a button out at the Clark Fork Valley Hospital in Plains. They had a problem with the helicopter landing and training fumes into the big air handler. So we put a button right on the screen that says helicopter. So that at the nurse station, when the helicopter's calls in, it's 30 minutes out, they can push that button and we will close those outside air dampers for, say, 90 minutes until the helicopter takes off. We don't smell that in the building. Same thing can be done with wildfire smoke. Again, you're going to know if it's dirty. I would say if you're changing your filters because of the smoke, I would probably check it every 2 or 3 weeks during the summer. Well, especially if you're going from like a MERV 8 to a MERV 13, keep your eye on how much we're catching. I think we're saving questions for the end. I'll leave some cards on the table if you have specific questions about the machine you have and what impacts the filters might have. We'd be happy to help you out.